Okay, page 74. Inverse functions, part 1. Inverse functions, not brand new to you. Okay, so a lot of what we talk about today should sound very familiar, but again, just like everything else, there are reasons why we are going through this. So we're focusing on inverse functions, but notice we start talking about inverse relations. An inverse relation will undo a given relation because they're all relations. Some of them just happen to be functions. And just because you have a function, if you take the inverse, it doesn't guarantee that the inverse is a function. It could just be a relation, but we'll get to all that. So every, and it's bolded, every inverse relation can be found by switching or exchanging, each x and y value. So you exchange x and y, switch them. And then you have your inverse right there, but most of the time we then solve for y so that we can write it as an inverse function if it is. All right, in some situations, this process is intuitive, meaning that it's kind of obvious, you know what to do, it's no big deal. But in other times, it may not be as obvious, In these cases, it is important that we understand the concept of the inverse relations as they will help us tackle a variety of problems. So a lot of times you know what to do, and you do it because your teacher said when you see this, do this, so you do it, but you don't understand the concept of why you're doing it, and that's why some questions, when they're asked differently, you're completely lost on, because it doesn't look exactly like the rest, where when we understand the concept, we can kind of apply it to other things. All right, so we're going to look at this numerically, graphically, and analytically. So tables, pictures, and equations. We're going to start with tables. Right? We're going to find the inverse relation of the given table. So here's our table. We have x and y values. Since it is the inverse, our x's and y's just switch places. So our list of y values, which is negative 1, 2, 0, 2, becomes our x's, and then our x's become our y's. 1, 3, 4, and 6. Everybody okay with that? All right. So then it says, the original table, blank a function. Is the original one a function or not a function? What do you think? Yes. Can you tell me why? So we're going to say it is a table because each what has exactly one what? Good. Each x value has exactly one y value. However, so that kind of gives away what the answer is to the next one, right? However, the inverse is what? Not a function. And why is it not a function? Okay, because we have repeating x's. So repeating x's is one way to look at it. And so because it has repeating x's, so that's not a wrong answer, but let's think about what that tells us. Since this one says each x value has exactly one y value, since we have repeating x's, we have an x value that has more than one y value, right? So because the x value 2 has 2 y values. I kind of wish the x value wasn't a literal 2, because then you use the 2 twice in the sentence and it makes it sound confusing. But basically because the 2 repeats itself. It is because we have repeating x's, because there's lots of different ways to think about it, but we want to make sure we know what one means, makes the other thing mean as we go through. Any questions on that? That is not new news, right? We know that. That's old business. All right. Oh, well, apparently this did not erase from last period, so, that's interesting. You know, I don't know what happened. Pretend like that green line isn't there. All right. We're going to sketch the inverse relation of so now we're looking at it graphically. That was numerically, now we're going to look at it graphically with pictures. And we are going to, so here's our steps. We list key points in a table, create a new table for the inverse by switching x and y values, plot the new points for each inverse, and sketch the inverse graph. So we're going to have our original little x and y values here. And it says key points. Well, in this kind of graph, the key points, what makes sense are the actual points where the little line segments connect. So this point here is -2, -1. This one is -1, 2. This one is 2, 1. And that one is 4, 3. All right, so there are our key points for our original. Then we're going to have the inverse. So then we switch them, and our y's become our x's, so negative 1, 2, 1, 3, and our x's become our y's, negative 2, negative 1, 2, and 4. All right, everybody good with that? Then we plot those new points. So now I'm going to plot negative 1, negative 2. I'm going to plot 2, negative 1. I'm going to plot 1, 2. And I'm going to plot 3, 4. Now, when we rewrote them, notice that we did not worry about, most of the time when you make a little t-chart, your x values go in order from least to greatest, right? Here, they don't, and we didn't worry about fixing them as we went through. Because even though, yes, we could have, the x values are not in order from least to greatest, but the points are in order in which you connect them. Because we have to think about how we're going to connect them. I cannot connect this one to this one just because it comes next. I plotted this point, then I plotted this point, then I plotted this one, then this one. So when I connect them, let me do it in a semi-decent way here. Oh, well, that's not good. When I connect them, I'm going to connect here, and then I'm going to connect here, and then I'm going to connect here. And you can use your ID as a straight edge if you want. It should be around your neck. You just plop it right up there. And when you sketch an inverse, it should look like a reflection of the original one. So if the shape's all wonky, that means you didn't connect the points in the correct order, and then you kind of know something's not right. All right, so the original one, the one that was graphed for us, is it a function? Yes, okay? And graphically, we usually look at the vertical line test, right? So saying, hey, the first one, it's a function, it passes the vertical line test. So that's how we know for sure that's not really the mathematical reason why. The reason that it passes the vertical line test is that so I'm going to start up here because I should have moved this second row down and I didn't, so there's not a lot of room to write here. So maybe I'll start over here. So I'm going to say original is a function, and that's because each x has exactly, and that word exactly is important, exactly, I can spell it, exactly 1 y. You agree with that? And that's why we pass the vertical line test, because each x has exactly 1 y. All right. So then, is the inverse a function? No. Okay? It fails the vertical line test, right? Does it fail the vertical line test over its entire domain? No. So if I look at this, I've got from negative 2 to 1, I'm fine. Like this part from negative 2 to 1, that part, if I just looked at that part, I'd say, yeah, this is a function. But then when I get to 1 right here, I start to fail the vertical line test, right? And then I continue to fail it all the way until I get to 2, right? So that little section of the graph is the problem. Would you agree with that? Okay. Kind of like the middle child. I'm just kidding if you're a middle child, but you probably get told that you're the problem, right? No. Very defensive. No. I'm just kidding. All right. So I only had 2. I didn't want a middle child. I'm just messing with you. Sorry. This probably wasn't a very nice thing to say, but y'all know I'm kidding. And again, I want to apologize. I'll apologize every day for coughing through the entire lesson and clearing my throat because I know it's annoying. All right. See if I can take a deep breath and speak now. All right. So now we're going to say the inverse. So I can say the inverse is not a function. And my reason there is not because it's the middle child, but because And I can say, because not every x has exactly one y, like that's okay, but I can be more specific here. I can say each x between 1, x equals 1 and x equals 2 has 2 y values. Or has, actually, 3 y values, right? More than 1, that works. That's better than counting them, right? More than 1 y value. Yeah, so saying more than 1 is fine, but I could have said that it has 3. Like I could get really, really specific there. Do you agree with all of that? Now, I want you to glance back at something real quick, and I'll come back if you're not finished writing that. But notice here, we were able to say, oh, look, in our chart, our x's repeat. So that x value has more than 1 y value. In our inverse chart, do our x's repeat? They don't, do they? But we also didn't have every single x value written down. Okay, so that's why it didn't show up in the chart, but it shows up in the graph, and we can answer it this way. Everybody okay with that? And then you can see, hopefully, that the original and your inverse, they are reflections of each other. I already had the line drawn in because apparently it didn't erase from last period. What is that line? It is the reflection line. Specifically, what's the equation? Very good. Yeah, if you just kept saying things that would come out, you're good. Y equals x. So graphical property of inverses. The graphs of inverses, and again, I wish I'd moved this down. I'm sorry, this is all crammed together. Are reflections, and maybe you have to write it below it and draw an arrow. That's okay if you can't write in the thing. Over the line y equals x, which should make sense because didn't we switch x and y? So y equals x and x equals y. We switch them, and then it reflects right over that line. So when you're graphing them, it is helpful to have that line drawn in. Any questions at all? All this is just kind of reminders, right? Hoping to kind of fill in a little bit more of the concept as we get through all of this. Can I switch? Can I flip? Okay. All right, so now, analytical, the equations. Here are our steps. We switch x and y, we solve for y, and then if the original equation was in the form of f of x, we write the inverse equation as f inverse. The way you say this is f inverse of x. Or the inverse of f of x. It looks like f to the negative 1 power. It's not actually a power, okay? We're not, because if it was to the negative 1 power, that means we take the reciprocal. Totally not what's happening. That's just what the notation looks like. We also have a reminder that f of x equals y, okay? So this time it is a function for sure. It's a relation, but the better name for it is a function. I'm going to just mark out the f of x and make it a y. And then we're going to switch x and y. So I'm going to get x equals 3y minus 7. Then I'm going to solve for y, okay? I'm going to add 7 to both sides, so x plus 7 equals 3y. Then what do I need to do next? Divide by 3. Now, when I divide by 3, I could make it into 1/3 x plus 7/3. Would you agree with that? The easier way to do it, and the perfectly fine way to do it, is just x plus 7 all over 3. That equals y. Totally acceptable. It keeps you from having to reduce or do anything else or make any mistakes. Okay? So now that we have solved for y, then I can say that f inverse of x is equal to x plus 7 over 3. Learn to just kind of stop. It wouldn't be wrong to write 1/3 x plus 7/3, but you don't need to, so don't do it in case something goes wrong while you make it that next step happen. We all good with that? All right. So the inverse notation, we've already said it, but we're going to write it again. The inverse notation is written as f inverse of x. Sorry. Try to come up the microphone too. I haven't gone to the doctor because they're just going to tell me I have a cold or it's my sinus issues and allergies, and they're not going to do anything for me, so I'm not going to bother. All right, finding inverses. So here are the steps. I'm not going to read them to you because we're going to do them. but they're there if you forget what steps or you get lost or confused on something when you're doing yourself. I don't know that you need the steps written out, but maybe. So this is what happens if we have more than one x value. So we're still finding the inverses just like we did before. Okay. So I'm going to mark this out and make that y. Then I'm going to switch x and y. And I'm going to get x equals y minus 2 over y plus 3. So that's step one. We switch x and y, right? So now our goal is to solve for y. Well, most of the time when you got a fraction, the first thing you want to do is get rid of the fraction. So I can get rid of the fraction by multiplying both sides by y plus 3. Now our goal is to get y by itself. We already have all the y's on one side, but I can't really do much with them. That's why I'm going to go ahead and clear the fraction here. I'm going to multiply both sides by y plus 3. So if I write x times y plus 3 equals y minus 2. Now, is what I have written down really what I intend to do? No. Okay. Now, and I've said this before, but I want to make sure you understand what I mean. In the past, if students had written this down and I'd be like, you know, you're going to have to distribute. Oh, I know. And then the next step, maybe they actually distribute and everything's correct. Not that big of a deal to me because you do know what you're doing. It does bother me that the notation's a little bit wrong and that you could make mistakes in the future. But it's a big deal on the AP exam. If you write this and actually do the correct thing the next step because you, quote, know what to do, you're going to lose some points because your work doesn't flow. Like this doesn't actually equal the next step. You with me on that? Because if I have these two terms, I actually need parentheses here. Whether I know that I'm supposed to do it or not, if I don't have them there and then I distribute, that's a problem because my work doesn't flow. Okay? It's a linkage error or some fancy term, I don't know. So now that I've got this here, I'm going to distribute this x. So when I distribute the x, I get x times y plus 3x equals y minus 2. So now that I have it as just like two polynomials, one on each side, the way you solve anything is whatever you're trying to solve for, you want to not solve anything. Let me take that back. Not a quadratic when you have to factor, but it's something linear like this. Or it's not linear. Just never mind. If I'm trying to solve something that looks like this, it's not a quadratic. I'm trying to get all of the y values on one side, all of the terms with y on one side, all of the terms that don't have y on the other side. So I've got x times y, and I've got a y. So I'm going to move this y to the left, so xy minus y equals, and then I still have a negative 2 over here, and I'm going to subtract the 3x over. Doing more than one step at a time because this is not an Algebra 1 class, and I should be able to do that without losing you. All right. Any questions at this point? Okay, so now, remember, my goal is to get a y equals type of thing. Is x times y minus y, does that equal x? No? It does not, right? So don't do that. You know that that doesn't happen. Instead, I want to factor out this y. So I get y times x minus 1 equals negative 2 minus 3x. Now what can I do to get y by itself? Divide by x minus 1. So now y equals negative 2 minus 3x over x minus 1. Everybody okay with that? So then my answer is f inverse of x equals negative 2 minus 3x over x minus 1. What questions do you have? Anything? Beautiful. Then you do B. Let me give you a minute to work through B on your own. I'll take attendance here. I guess we need to actually. Talk to your neighbors when you're done. Check your answers with each other. Do not just copy mine down. going to go back to it, but I'm going to make sure that you finish first before you just copy mine down. Okay? Yes, it's the same thing. That's why I didn't want you really looking at mine just yet. I just wanted to get it written up there. Anybody stuck or have a question? You're just not finished. That's okay. And when we get to this point, when I do put mine up there, yours might not look exactly like mine. It does not mean that you are wrong. Okay? So don't start erasing things. Are you good? Yeah. You're all good? You got it wrong. You solved for x. What did you do? Okay, this is right.
Oh, wait.
Oh, yeah. What you're good to hear. And then you just went back to what you had. You see what I mean?
Wow.
It's okay. Yeah, that's okay. That happens. That's why sometimes in the middle of things, you have to remind yourself what you're solving for. Because everything you did was, you didn't do anything wrong. You just kind of went in a circle and didn't really finish the problem. So, okay. Anybody else have any questions? Are we good? Can we talk about it? All right, so I'm going to go back. Now, remember what I just said. If yours doesn't look exactly like mine, it does not mean that you're wrong. We'll talk about it before you start erasing anything. All right, so I left mine like this. If you have this, oh, well, this actually should look like an X. Oh, good Lord. Doesn't look like an X. Well, whatever. You know that's an X. If yours doesn't look exactly like mine, could you tell whether or not they're at least the same answer? Yes, hopefully. Now, so what you probably wouldn't have that would be the same, you might have 3x plus 1 in the numerator. Totally fine. Is that more of a proper way to write it? Absolutely. But I left it like this kind of on purpose because just because that's how I wrote it down, and it's fine to leave it like that. You don't have to flip it around. Most likely, if it was written for you in an official, like, this is how you solve it, 3x plus 1 would probably be what's there. But again, it's the exact same thing. Okay? Any questions about this? We good? And again, the steps are there if you get lost in it or you start going in circles and realize that you're, whatever, they're there. Okay. Any questions at all? All right, grab your next sheet of paper. This is also going on page 74 when we're done. All right. We know that to find an inverse, we simply switch the x and y values. We just talked about that. Graphically, this means that a function and its inverse will be reflections over which line? Y equals x, and that is the parent function, the linear parent function, right? All right, so the one we did was just simple line segments. If a graph is not made up of simply line segments, sketching the inverse can be challenging. To do this, we use the fact that the function and its inverses are reflections to help us sketch. So here's our steps when they're non-linear pieces, which is not that much different than linear pieces. Okay, so we sketch the line, y equals x, on the graph. We mark any points from the original graph that are already on the line. These points stay in the same place because it's just like attached to the line as it flips around. I select a few additional points on the original graph to find their inverse points. Well, we already did that, but those were just like actual points where things were connected, so they were really obvious and really easy. You can find the inverse points by either switching the x and y values or graphically reflecting each point over the line y equals x by drawing a line perpendicular. So perpendicular, we're going to write out the entire word. This has probably been a while since you've actually written that word. Perpendicular. Who can tell me what the symbol for perpendicular is? What does it look like? Yeah, looks like an upside down T, right? That means perpendicular. Which usually I do that and don't write out the word, but because we haven't actually used the word before, I want to make sure everybody knows what's what there. And extending equal distance. Now, this seems a little extra to me, okay? And by that, I mean, you are not going to have to actually graph these inverses on the AP exam. There's no way, okay? You're going to have to compare things or whatnot. So again, we're trying to get you to the concept. So although this works and we'll talk about it, we're still going to kind of do it like we did the other one because it's going to get us a good enough idea of what we have, which is really all we're going for anyway. And then we sketch the inverse. All right, so let's look at this first one. Now, the line's already there because, again, for some reason, even though they always do, these didn't erase from last period. So And I would maybe do a dotted line if I were you and not just like a solid one because it could get confusing. That's why I did mine with a bright green line here. So we draw in the line y equals x, or sketch it in, or dot it in, whatever. And then we're going to first mark the points that are actually on the line. So here and here. Okay, so you can think about it just being attached, and it's just going to reflect over. Now this is a parabola. And when I reflect it and I take the inverse, it lays it down like this, right? So you kind of already have an idea of what's happening. But even if you don't, I mean, you should think, even if you can't like picture what it is, you kind of know how it's flipping around. So let's find some other key points. I see this one, which is at 0, 4, which means my new point would be where? If this is at 0, 4, then I would be at 4, 0, right? Just switch x and y. And I probably shouldn't have actually put a point there because then it might get confusing. So let me take that off. Then another point I see that's pretty good here is this 2, 0. So 2, 0 would now be where? 0, 2. Okay. Then I also have this point here at 3, 1. That would now be at 1, 3. Now, do you feel like that is enough points for you to sketch this in? I would say yes, right? So then we can just sketch this in. Again, if kind of even doing this dotted at first might be helpful depending on, I mean, for me, it's not going to help on this board, but it's not an art class. We're trying to get things in the general spot and understand the general concept here. That is the line y equals x. That's what we are reflecting over. So this right here, that's why these 2 points stay the same. It's just like attached to it and it just like flips around like it was a flag or something. Okay? And if we were going to, so it did say what we could do is draw a perpendicular line. So this point here, 3, 1, if I drew a line perpendicular to that green line, it would be like that, right? So I go a diagonal through one of the squares. I do that. That's why I end up over there. Because these two little pieces are congruent. And it's perpendicular to that line there. So you could sit there with like a ruler and whatever and kind of get some other points that way, but totally not necessary. Everybody okay with that? All right, so let's look at B. Draw in your line y equals x again. And then I'm going to mark the points that are on the graph because they stay there and they're points that can help me for sure, even though I don't know the actual x and y values there. And then let's find some points that are actually easy to graph, like negative 2, 0 is right here, so that becomes 0, negative 2. And you can see that from this point to this point, if I drew a line perpendicular, then the line y equals x would bisect it. Another point that's easy is 1, 0, so that becomes 0, 1. I think two other very helpful points would be the relative maximums and minimums. Would you agree with that? And they're not like points that I can actually know exactly what the number is by this. I could draw my perpendicular lines and whatnot, but we're not going to get out the drawing tools and doing that by hand. It's just going to be a hot mess. I mean, even when I do it, I'm not insulting you. So instead, we're just going to kind of ballpark them. I would say that this relative minimum right here, the x value looks like it's just past halfway, and I would say the y value looks like it's just past halfway. Would you agree with that? So we're like at kind of 0.6, negative 0.6 maybe. So if I'm at 0.6, negative 0.6, then I'm going to go to negative 0.6, 0.6 kind of right there, where those are kind of in the same spot as a reflection. This one, I would say my relative maximum there, it's like it may be negative 1.2, 2.1-ish. Good little guess there. So negative 1.2, 2.1 would be like 2.1, negative 1.2, so maybe somewhere kind of right about there. And then, can I sketch this in at this point? Because I know what the general shape should be, right? And I know that this point reflected down here and this point reflected from here. So I know that, this point reflected from here. Then those are it should go in kind of like that. I missed that last point, but the rest looks semi-decent, so I'm going to leave it. But just trying to get the concept. We're not going to spend forever graphing these because, like I said, you're going to need to be able to recognize it. You're not going to have to be an expert at actually drawing it. But actually, sketching some of them does help us understand the concept. That's the idea there. We doing okay? All right. So I think because I still have 3 or 4 of you to talk to, we are going to stop here today. I'm going to give you your assignment. And yeah, we have gotten through everything that is on the assignment, so you should be fine. This kind of goes with the next assignment anyway.